Welcome pre-cal students to the homework help video, page 544, numbers 1, 3 through 5, 7 through 9, 11, and 13 through 16. Go ahead and get your books open to this page, get out your homework, pens, pencils, paper, calculators, whatever you need, and let's go ahead and see if we can't get you guys a little help, all right? Here we go. Problem number 1. The directions for 1 through 8 state to multiply and then simplify, okay? So here's the answer we're trying to get, by the way. We're trying to get this answer out, and I told you guys to look in the back of the book first for these problems if you want to. So sine squared minus cosine squared. Well, let's go ahead and do the multiplication, shall we? Here we go. We take sine times sine and then sine times cosine. So sine times sine would be sine squared x. And then sine times cosine, positive times a positive will be positive sine cosine. Very good. We're done with this. Now let's be careful now, it's a negative cosine. Take your negative cosine and multiply it through. So negative cosine times sine, negative cosine times positive cosine. Negative cosine times positive sine. Well, negative times a positive is negative. Sine times cosine, or cosine times sine, excuse me, would be cosine x sine x. And then negative cosine times positive cosine would be negative cosine squared x. Now, students, I've taught you a long time ago in algebra, if you have a term that's labeled xy and a term that's labeled yx, they're like terms. Okay, it doesn't matter what order the letters are written as long as the exponents match. And so, with that in mind, sine cosine is the same thing as cosine sine. So a positive 1 sine cosine and a negative 1 sine cosine, they're just going to cancel out. Okay, it's pretty unorthodox to put 0 sine cosine. Okay, that's pretty weird. So we're just going to say they cancel out. So now we're going to bring down our sine squared and then bring down our negative cosine squared, and look at that. There's really no more simplifying to do. We're done. So we did our multiplication, and we know we're good. Let's take a look now at number 3. Now the answer that we're supposed to get for number 3, according to the book, is sine y plus cosine y. Now, let's go ahead and do, excuse me, let's go ahead and do our multiplication. We have cosine sine, that's one term. That's one term. They're multiplying. Cosine sine times secant. So that would be cosine y sine y secant y. And then cosine sine times cosecant. That would be plus cosine y sine y cosecant y. Okay? Now, we've got to take this big mess and somehow turn it into this here. Now, I will say this, guys. Do you notice what you want to have in your first term here? Sine. And look what I have right here. Sine. So maybe these two would cancel out if I wrote them side by side. So I'm going to go ahead and put sine first, which you can move them around. They're multiplying, so it doesn't matter. And then for cosine, I'm going to put cosine over 1. And then for secant, I'm going to put 1 over cosine. Haha, cool, huh? Look at that. Looks like some canceling will take place. Now look at your answer here. You want to have cosine. And I see a cosine right here, so maybe these two will cancel out if I can make a substitution. So positive cosine, and then for sine, I'm going to put sine over 1. And then for cosecant, I'm going to put 1 over sine. You'll find that on your basic identities page. Look at that. Now go ahead and multiply these two together. Cosines would cancel. 1 times 1, 1 times 1 is 1 times sine would just be sine. Then over here your sines cancel. And 1 times 1 is 1, 1 times 1 is 1, and 1 times cosine would just be cosine. Sorry about that. My computer's doing weird things again. Cosine y. There we go. Let's move on and try the next one. Number 4. Now, they want us to get this answer right here. Let me look in the book. They want us to get 2 plus tangent x, that is a plus sign right there, 2 plus tangent x plus cotangent x. So let's see if we cannot oblige them and figure this out. The first thing we're going to do is take our sine and multiply it through like that. So sine times secant will be sine x secant x. By the way, you're going to do a lot of writing. It's really annoying. Just your hand's going to hurt after a while. So sine times secant, and then sine times cosecant would be sine x cosecant x. So good, I'm done with my sine. Now take your cosine and multiply it through like that. So cosine times secant would be cosine secant. Notice I'm writing small, just squeeze it in here. And then cosine times secant, or times cosecant, would be cosine x cosecant x. Now, wow, this is pretty interesting here. I think what I'm going to have to do is use some, what do you call it? Some basic identities, some inverse identities. For example, how could we do? Okay, secant right here. Now watch this. Watch this carefully. Secant, I'm going to put sine over 1, and secant here would be 1 over, let me back that up there, 1 over cosine. Now I'll explain later why I'm doing that. Now, let's take a look at my sine and cosecant. I'm going to put my sine, now I have a method, all my madness, sine over 1. Mr. Earhart, by the way, cosecant is 1 over sine. I wouldn't have thought to have done all this. Okay, let me just stop it and tell you what I'm trying to do, okay? Watch. I thought ahead, and I said to myself, if I put 1 over cosine for secant and put sine over 1, when I multiply these two, watch what happens. Sine times 1 is sine. 1 times cosine is cosine. Well, Mr. Earhart, you've gone crazy. How does that help? Well, I'm glad you asked. If you'll look at your basic trig sheets, it says that sine over cosine, well, hold on, so all of this became this, and now all of this, look at your basic trig form. Sine over cosine is tangent. So now I can simply put tangent x. Look at that. Why do I care? Look at your answer. Somewhere you want to have a tangent x. Now look at why I put cosecant x as 1 over sine x. What happens to your sines, guys? They cancel out. 1 times 1, 1 times 1, that would be a positive 1. Now, and that's fine because I want to get a 2 somewhere. Well, later on I'm going to get another 1, then 1 plus 1 will give me 2. Just watch, you'll see. So, with cosine here, I'm going to go ahead and put cosine over 1, so cosine x over 1. And then for secant, I'm going to put 1 over cosine. And I did that because now my cosines will cancel. 1 times 1 is 1, 1 times 1 is 1, so now I have a plus 1. See? This is really falling into place nicely. And now over here for cosine, I'm going to put real small, cosine over 1 times, now cosecant is 1 over sine. Well, does that help? Sure it helps. Now, watch what this whole group becomes right here. This whole group becomes this. Watch. Cosine times 1 is cosine x. 1 times sine is sine x. Is that a big help? Sure it is. Look at your basic trig form, your basic trig identities. Cosine over sine is cotangent. So now I have positive cotangent. And then look in the middle right here. 1 plus 1 is a positive 2. So this thing is spread out really big. And all you got to do is just move things around. Like in your answer here, they want the positive 2 first. So just grab the positive 2 and put that, well, we're going to put it, I guess we'll put it over here for just for a second. They want the tangent x second, so we'll put that right here. Move this here. Move that there. There we go. Booyah. I think that's pretty cool. A lot of work, and I'm sure you probably struggled on that one, but it's good practice for you. All right, number 5. The answer for number 5 is 1 minus 2 sine cosine. So 1 minus 2 sine cosine. So let's go ahead and write, I'm just going to use an x. In the very end, I'll change it back to this weird thing. Sine x minus cosine x. Sine x minus cosine x. There we go. Let me grab a drink of water real quick. Okay, here we go. Well, we take our sine and multiply it through. Sine times sine is sine squared, and sine times cosine would be negative sine cosine. Good, we're done with this. Now take your cosine and multiply it through. Cosine times sine would be negative cosine sine. And then negative cosine times negative cosine is positive cosine squared. Now, look at the answer they want you to get up here. Somewhere you're going to have to get a 1. So I'm going to go ahead and write sine squared x plus cosine squared x. I'm going to put those two side by side, because if you'll look at your Pythagorean identities, sine squared plus cosine squared is 1. All right. Now we have a sine x, a sine cosine, and a sine cosine. They're like terms, a negative 1 and a negative 1. So combine those and you get a negative 2 cosine x sine x. Okay. Combine those two and you'll get this. Now sine squared plus cosine squared is 1. So this whole thing here became a 1. And then bring this expression down right here. Just bring that down right there, and you have the correct answer. 1 minus 2. Well, they have, look right here. This is not a big deal. I'd give you full credit on the test. They have 1 minus 2 sine cosine. You have 1 minus 2 cosine sine. Well, look, they're multiplying. It really doesn't matter which one you put first. The only thing you might want to do differently, just to be consistent, instead of having x's here, you probably want to have the unknown that they had in the original problem. Okay, but that's how you do number 5. All right, number 7. Let's see, the answer for number 7 would be sine cubed plus cosecant cubed. So sine cubed plus cosecant cubed. And here we go. Let's take our sine and multiply it through. Sine times sine squared would be sine cubed. Sine times cosecant would be sine x, cosecant squared x, and sine times negative 1 would be negative sine x. So I took this sine right here and I multiplied it through times each term. Okay. Now let's take our cosine x and let's multiply it through times each term. So cosecant times sine squared would be positive cosecant sine squared, and then cosecant times cosecant squared would be cosecant cubed, and then cosecant times negative 1 would be negative cosecant x. Now I did make one mistake in the answer right up here. They want this to be a 3. Okay? That should be a 3 right there. All right. Well, somewhere in your answer, guys, look, you want to have a sine cubed x. Do you see that? And don't we have that right here already? So I'm going to go ahead and cross this off and just bring it down for my final answer. So sine cubed x. All right. Now, somewhere they want to have a cosecant cubed x, and I see that right here. So I'm going to go ahead and bring that down. Now, somehow, all the rest of these terms need to cancel out. And I'm not trying to be dramatic. I really have no idea how we're going to do this, okay? So let's just kind of think this through and see what we can come up with. Probably the best thing to do is to start making some inverse substitutions, see what we come up with. For example, sine x over 1 times 1 over sine squared x. Remember, if you have a cosecant, cosecant is the same thing as 1 over sine. Well, think about it. If you have cosecant squared, that's the same thing as 1 over sine squared. So now let's see what happens to this whole group right here, okay? So I'm going to cross this off. I'm done with those. They've now become this. I have one sine here and two sines here, so we'll take one sine away, and we'll take one sine away from here. 1 times 1 is 1, so I get 1 over 1 times sine x. Positive. Okay, that's fine. So this whole expression here, all of this, simplified down to this. All right, fair enough. Now let's continue on. Now let's take a look at this right here. Negative sine x. Really not a lot you can do with that. So as of now, I might change my mind later. I want to bring this down. I'm just going to put negative sine x. I might change my mind later, but we'll see. Now let's take a look at this term. Now I'm thinking here for a second. Hold on. For sine, for cosecant, I could just leave it cosecant. And then for sine squared, I could put 1 over. I don't know if I really want to do that, to be honest. I'm trying to think. Maybe I should do the other thing. Maybe I should say, yeah, let's try this. Instead of cosecant, let's put 1 over sine. And then sine squared, we'll just leave it over 1. That'll work. Now here's why that works. Watch carefully. This sine right here would cancel into this one time with the sine. In other words, let me do that again. I don't think I explained that very well. Okay, you have two sines here and one sine here, so take one away from that one, take 1 away from this one, and look what you're left with. 1 times sine squared would be, or excuse me, this would just be sine right here because you took one of the sines away, so it would just be sine x right here, sine x. So 1 times sine x would be sine x. 1 times 1 is 1, so you end up with a positive sine x. So this whole group right here, that whole term, was broken down to this, and then we got this. By the way, those are going to cancel out in a second. Now, this is so cool. Look, guys, negative cosecant x. Well, what is negative cosecant x? Negative 1 over sine. I mean, what's the inverse of cosecant? 1 over sine. Look what happens, guys. You've got a negative sign and a positive sine x. They cancel out. You've got a positive 1 over sine and a negative 1 over sine. They cancel out. So you brought down your sine x cubed. You brought down your cosecant x cubed. Or cosecant cubed x, however you want to say it. And everything else canceled out. So we did it. Our answer matched the answer we were supposed to have. So that's a pretty tough problem. It was good for you. All right. Now, number 8. I believe this is our last one when it comes to multiplying and then simplifying. The answer for number 8 should be cosine squared. I don't think this will be that hard. Cosine squared t. All right. 1 times 1 is 1. 1 times sine t is sine t. And then sine t times 1 would be negative sine t. And then negative sine times positive sine would be negative sine squared t. There we go. Now, you have a positive sine t and a negative sine t, so they cancel out, and you're left with 1 minus sine squared t. Now, there's a Pythagorean identity, if you look at your Pythagorean identities, that says sine squared t plus cosine squared t equals 1. Everybody see that? It's on your Pythagorean identity sheet. But hold it. If I took this sine squared right here and brought it to the other side and made it negative, I would then have cosine squared t equals 1 minus sine squared t. So there we go. And so now for sine squared t, no, excuse me, Did I move the wrong thing? I hate it when I do that, guys. Sorry about that. I moved the wrong thing. If you bring the cosine squared over, you would have sine squared t equals 1 minus cosine squared t. So for sine squared t, you could put 1 minus cosine squared t. That would be one option. But I'm thinking of this. Here, I think the best way to do it is just simply this. This is probably the least confusing way. Look at your trig identity right here. All of this just equals what? 1. So where the 1 is, I'm simply going to put sine squared t plus cosine squared t. So for 1, I put all of that, okay? And then bring down your negative sine squared t. So negative sine squared t. And now these will cancel. I have a positive sine squared t and a negative sine squared t. They cancel, and it leaves me with cosine squared t, which is what I'm supposed to have. All right, now let's go ahead and get into the factoring problem. So here we go. Now we're looking, hold on one second, please. Now we're looking at number 9. So numbers 9 through 16, they're going to want us to factor first and then simplify. Now don't forget, you factor before you look at the answer. So I always pull out what's common first. I have 1 cosine here and 2 cosines here, so I can definitely pull out a cosine. And when I pull out a cosine, I'm left with sine x plus cosine x. Now, as I look at the answer in the back of the book, yep, that's what you're supposed to have right there. That's it. So there's no simplifying they want you to do. That's all they wanted you to do is factor, and then no simplifying. Let's take a look at number 11. Well, you know what? I know the square root of sine to the 4th, and I know the square root of cosine to the 4th, and there's a minus sign here. So the first thing I can do when I factor is the square root of sine to the 4th is sine squared. So sine squared x, and then the square root of cosine to the 4th is cosine squared. Make one positive, make one negative. Now we can factor some more. I'm sorry, but that's just how it is. You cannot factor this parentheses. Well, yeah, you can, Mr. Earhart, because we know the square root of sine squared and we know the square root of cosine squared. Yeah, you do, but remember this middle term here has to be negative, and it's not. So you cannot factor this expression here, but you can factor this expression. So I'm going to go ahead and bring down, and actually I'm going to get a little lazy here, or try to get lazy. We'll see what happens. I'm going to grab this and bring it down, okay? And now I can take this parentheses here and I can factor it some more. The square root of sine squared is sine, so I put a sine here and a sine here. And then the square root of cosine squared is cosine, so I put a cosine here and a cosine here. Make one positive, make one negative. Now, I'm looking at the answer sheet. I'm done factoring now. Let's see what number 11 wants. Okay, what they want you to do, they just want you to have this for your answer right here. That's it. And so we're going to have to think of a way to simplify this parenthesis. So hold it. If you look at your Pythagorean identities, you will see that sine squared plus cosine squared equals 1. So really for this whole parentheses right here, I can just put a 1, and then 1 times anything is just itself. So your answer then would be sine x plus cosine x times sine x minus cosine x. Very cool. Moving on. All right, number 13, we're going to factor this. Now remember what I've taught you. I would encourage you to write it with just without the cosine. So I would write 2x squared plus 1x minus 3. Now, where did I get 2x squared? Well, there's a 2 out front, and it's cosine squared, so x squared. And then there's a 1 right here in front of the cosine, so instead of cosine x, it's 1x minus 3. Now, we know how to factor this trinomial. There's nothing common you can factor out, so you should know what to do. The next step is to take this number here and this number here and multiply them together. and write the result out there. So we'd get a negative 6. And then what two numbers, when multiplied together, give you negative 6, when added together give you a positive 1? Well, that should be a positive 3 and a negative 2. If you multiply those, you get negative 6. If you add them, you get a positive 1. So remember, I bring down my 2x squared, and I bring down my negative 3. And then I take these two numbers here, and I replace this positive 1x with these two numbers here. So instead of putting a 1x, I put 3x minus 2x. Very good. Now, what can I pull out that's common in the first two terms? An x. And when I do that, I'm left with 2x plus 3. X times 2x, 2x squared, x times 3, 3x. Now, remember when this first term here out of these last two terms is negative, you plot a negative sign, and there's nothing you can factor out, nothing, so we put a 1. Now be careful with your signs. A negative times a positive, let me fix that, my computer's freezing up again. A negative times a positive 2x is a negative 2x, and a negative times a positive 3 would give me a negative 3. So negative times 2x, negative 2x, negative times 3, negative 3. And now you have your matching parentheses, 2x plus 3, and then your other parentheses would be x minus 1 from here and here. So now we come up here, and now we put cosine back in. So 2x plus 3 would be 2 cosine x plus 3. And then x minus 1 would be cosine x minus 1. Now I'm just going to create some space here and get rid of all this work. So that factoring over here without the cosine helped me factor it over here. Now let me look at the answer. That is as far as they want us to go. Okay, so we're all good with that one. Moving on to number 14. All right. Now again, I would encourage you to write 3x squared minus 6x plus 3. Now if I gave that problem to you right there and I asked you to factor, the first thing you do is you pull out what's common, which would be a 3, and you're left over with x squared minus 2x plus 1. 3 times x squared, 3x squared, 3 times negative 2x, negative 6x, 3 times 1 is 3. So there. Now look at your trinomial that you're left over with. You're left over with a trinomial that has a lead coefficient of 1. I'm going to go ahead and get rid of this 3. I don't need this 3. Pull it way down here for my final answer. Now, what two numbers multiplied together give you 1, when added together give you a negative 2? Well, I right away think of these two numbers. Negative 1 times negative 1 is 1, and when you add those, you get a negative 2. So I'm now going to write x minus 1, x, and guys, I'm really not making an excuse. My computer freezes up, and then it kind of jumps ahead. X minus 1. All right, so there we go. And now don't forget you should have a 3 out front, so I'm going to slide that right down there. So there. We took this trinomial right here, pulled out the 3, and then factored, and we get this right here. So let's go over here now and let's put our cotangent back in. So I have 3 parentheses, cotangent x minus 1, and then parentheses, cotangent x minus 1. Now let's see if they want us to take this any further on number 14. It looks like all that they want us to do is simply write 3, and then because your parentheses are both cotangent x minus 1, they had their final answer written like that. I would accept this, however, I would also accept that too for an answer. All right, let's continue on to number 15. Number 15. All right, now again, my suggestion to you is to write x cubed plus 27. And now if you remember how to factor this, you should be home free. I know the cubed root of this term. I know the cubed root of this term. So I put a little parentheses and then a big parentheses. The cubed root of x cubed is x. The cubed root of 27 is 3. Whatever that sign is, you bring it down and you put it right there. And then remember, whatever this term is, you multiply it by itself. So x times x is x squared. So I put an x squared here. And then next, I take this term and multiply them together. So x times 3 would be 3x. So I put that here. And then I take this term here, and I multiply it by itself. So 3 times 3, get this working here, would be 9. Next would be your sign sequence. Whenever this is positive right here, then your sign sequence over here goes positive, negative, positive. Now, I've looked in the, you factored, and that's good. And let's go ahead and put sign in now. So for x plus 3, it should be sine x plus 3. And then for the other parentheses, for x squared, that would be sine squared x. And then negative 3 sine x, and this simply plus 9. Now, I've looked in the back of the book, or the teacher's edition I have here, and that's all they want you to do. So there's no simplifying to do from there. They just wanted us to factor, and that's it. All right, number 16. Well, again, I want to encourage you to write it in a way that looks familiar. 1 minus 125 s cubed. All right. I think I might go ahead and use an x just to make it a little easier. X cubed. Now I do know the cube root of 1. I do know the cube root of 125. And I also know the cube root of x cubed. So I know the cubed root. So I'm going to put a little parentheses and a big parentheses. The cube root of 1 is 1. The cube root of 125x cubed is 5x. Because 5 times 5 times 5 is 125. And x times x times x is x cubed. Now notice your sign right here is negative, so I put a negative sign here. Now take your first term, this 1, multiply it by itself. 1 times 1 is 1. Now take the 1 and the 5x and multiply them together. 1 times 5x is 5x. And then take your 5x and multiply it by itself. So 5x times 5x would be 25x squared. Now whenever you have a negative here, everything over here is positive. So positive, positive, positive. Now I'm going to quickly go ahead and rewrite this with tangent. So I have 1 minus 5 tangent x. And then 1 plus 5 tangent x. And then plus 25 tangent squared x. Now I know I shouldn't have used an x, I should have used an s, but I think that's the final answer. Now I've got a teacher's edition, so I've got the even answers. I'm going to look here and see, and yes, that's as far as they wanted us to take it, and so we're done. So that's it. Hopefully this homework help video has been a help to you. Call or email if you have any questions, and please continue to work hard.